Okay, so we continue with differentiating. This I'm going to differentiate when we have two or more terms. So copy the learning objective down. When you're ready, hit play, and we'll look at an example. Right, if we recall our rule for differentiating, we have, say, y equals x to the power of n, x to the power of n, then dy over dx given by the power multiplied by x to the power of, and we subtract 1. And if we have a constant, so if we have y equals a times x to the power of n, constant term a, then the gradient or the differential dy over dx is given by a times the power n x to the power of n minus 1, subtract 1 again. So we're going to use those two rules. What we have though this time is we have more than one term. So we do term by term differentiation. So if we just write what y is equal to here, y is equal to x squared minus 6x minus 4. So when we differentiate it, dy by dx, do each term at a time. Differentiating x squared, it's going to give us 2 to the power of x, subtract 1, so it's 2 to the power of x, minus 6, the constant. Well, technically that's to the power of 1, but we subtract 1 from it, so it becomes to the power of 0, which disappears, and the constant, we ignore the constant. Good, so that's that done. Copy the example down. When you're ready, hit play again, and we look at another example. In this example, it says find the gradient of the curve y equals x cubed plus x squared when x equals 2. So I'm going to do this, I think I'll do this over here. So we got y equals x cubed plus x squared. So term by term differentiation gives us, take the power, 3x to the power of 2, subtract 1, plus 2x. So that's our gradient. Then when x equals 2, then dy over dx is equal to, we sub for 2 wherever we got x, 3 times 2 squared plus 2 times 2, which is equal to 3 times 4, 12, plus 4 equals 16. Okay. At x equals 2. Hit pause, copy that example down. When you're ready, hit play again, and we'll move on. Okay, so we want to find the gradient of this curve at the point 1 and 13 over 3. So let's write our equation here. Where is it gone? There it is. Y is equal to a third x to the power of a half plus 4x squared. So dy by dx, differentiating term by term. First one, to keep our constant the same, a third, times the power, which is a half, of x, and then we subtract 1 from a half. So a half minus 1 gives us minus a half, plus 4 times the power of x to the power of 1. So if we simplify that, we've got a sixth of x to the power of minus a half plus 8x. And we can write that as equal to 1 over 6 x to the power of a half, which is the square root of x, plus 8x. Now we want to find the gradient at the point 1, 13 over 3. So that's our x coordinate, which we require, that's our y. I'm going to use the x one. So we say at the point 1, 13 over 3, dy over dx is equal to 1 over 6 square root of 1 plus 8 times 1. So that's 1 over 6 plus 8, which is equal to 8 and a sixth, really. That's it. So hit pause, copy the example down. Once you've done that, hit play. We'll move on to another example. Okay then, so we've got this example. Find dy over dx when y is equal to a quarter root x. So let's do that then. We've got y is equal to 1 over 4 root x. Now square root of x, I can rewrite that as 1 over 4x to the power of a half. Difficult to differentiate it in that form, so what I'm going to do is I'm going to write a quarter of x. The reciprocal of x to the power of a half is x to the power of minus a half. Now that I can differentiate. So dy by dx is equal to a quarter. I'm going to multiply it by the power, which is minus a half, times x, and then I've got to subtract 1. Minus a half minus 1 is equal to minus a half minus 2 over 2, which is equal to minus 3 over 2. So that's x to the power of minus 3 over 2. And if we simplify that, it's minus an eighth of x to the power of minus 3 over 2. I'm happy with that. You can leave it as in that form. You could rewrite it if you wanted to as minus 1 over 8 x to the power of 3 over 2. And I'd leave it at that then, I think. Okay. Just be aware, if you ever see it in this form, minus 1 over 8 square root of x cubed is the same thing. Right, but not necessary. This is good enough. So hit pause, copy the example down, and then we'll move forward. Okay, then let's have a look at this example. Find the gradient of the curve y equals x minus 2 over x squared at the point 2, 0. So we've got our y, which is equal to x minus 2 over x squared. And we want to find the gradient at the point 2, 0. So first we've got to differentiate it. Tough to differentiate, so what I'm going to do is I'm going to rewrite it as x divided by x squared minus 2 over x squared. Half the difficulty with these is just recognizing what you've got. Simplify further, that's 1 over x minus 2 over x squared. Now if we write the reciprocals, y is equal to x to the power of minus 1 minus 2x to the power of minus 2, which is much easier to differentiate. And dy by dx is given by, take the power, so minus of 1, so it becomes minus x to the power of, subtract 1, minus 2, minus 2 times the power, which is also minus 2, x to the power of, subtract 1, so it becomes minus 3. So be careful with negatives. Simplifying, we've got minus x to the power of minus 2 plus 4x to the power of minus 3. So we can say that's equal to reciprocal minus 1 over x squared plus 4 over x cubed, and at 2, 0 the gradient is equal to minus 1 over 2 squared plus 4 over 2 cubed, which is equal to minus a quarter plus 4 over 8. So minus a quarter minus a half, or minus a quarter minus, minus a quarter plus a half, or minus a quarter plus, minus a quarter plus 2/4, which is equal to a quarter. Right, so hit pause, copy that example down, and I've got some classwork for you. So exercise 12E, page 267. I would, it's going to be quite quick, so I would go through them all. It's just the 7 questions, and I think the practice of differentiating is invaluable. So off you go.